Welcome back, my fellow duplicants. Today I'm going to show you how to set up the automated metal refining inventory system here. So this allows you to automate the inventory system for your refined metals, and you can also get some of the power back out of this to send it off into your base. Super useful, very nice, and takes a lot of the load off of managing your inventory. So here's how to set it up. Alright, so welcome to my test lab. Let's go ahead and set up this blueprint. So I have a couple different blueprints here, one that is set up to run from left to right, the other from right to left. So you can see this one right here, because you have the storage bin before the smart storage bin, if your duplicant's running from right to left, that's the way you're going to want to use this one. The other arrangement works from left to right, so again, same sort of thing, you can just tell depending on where the storage bin and the smart storage bin are. So those are the two different blueprints that I have here for the metal refining system. Now to explain why this is the way it is, I already did a whole video on all of that. You can check it out right up here. And there's other ways to automate the metal refining and other pieces of equipment as well that I kind of cover there. This is just with the system that I like to use inside of my base. So once we have the metal refining system set up right here, obviously you're going to want to build it on top of some tiles. You need to cool down the liquid that's running through the metal refinery. So to do that, we're going to want to use the cooler. So this right here is the cooler that I'm using in my Surviving Oasis series. Now when you build this, there's a couple things that you need to keep in mind. One, this area right inside of here needs to be a vacuum. So you'll have to set up a little bit of a liquid lock or something like that and pull it into a vacuum. And then what you're going to want to make sure is that you have a little bit of water inside of here. I find a good amount of water is just 1,000 kilograms worth. So it looks just like this. We have a little bit of water and then a vacuum above that. You're good to go. Now in my example here, I have a cooler that can sustain up to 5 different metal refineries. You can build this smaller if you want, or you can kind of rearrange the loops however you want. I've done it differently in a couple of my different playthroughs. But this one from the Surviving Oasis actually works out pretty good. The one thing I would note here is that if you do a liquid sensor and this shutoff here, you might actually want to place that right underneath this, depending on how your layout situation works. Or you can put it right down here on top of the blueprint. I've just left it as part of this blueprint and not part of that blueprint, so you know, you can make that work. But you can also just use the copy tool like this if you really wanted to and just move it right up here like that. And that'll do the same sort of thing. But essentially, you just need to connect these two together just like that. Boom. I'm using insulated ceramic. That's a really good way to go down here because these liquids are relatively hot. Obviously, we need to connect the power to this stuff. The wire should be kind of routed to the wall, but I don't know what your power grid looks like, so it's just going to have to be something like that. So now that we have power, we're going to want to fill up the metal refinery here with the coolant that it will run through there. That's actually going to get hot. For that, I like to use crude oil because it has a great temperature range and it's relatively, readily available. And I like to bring the liquid in just before the input of your liquid reservoir right here. So to do that, I just create a T-junction right here and maybe like a T-junction right there. Okay, so the reason I use a T-junction is for this reason right up here, because if you actually had a bridge dropping on there, it would stop and you would never be able to actually force liquid into this reservoir. And that's what you really want to do. You want to have a little bit of liquid inside this reservoir because that's going to balance the temperatures. But once you get all the liquid you need in there, everything runs smoothly. Alright, so now let me explain the automation of what's going on here. So this is a cooling loop. So essentially this is looking for anything that is above, let's say 50 degrees Celsius. And if it's above 50 degrees Celsius, then the thermal aqua tuner is going to be enabled. And because that is the first spot where any crude oil can go, then guess what? It's going to jump through the aqua tuner first. But once we go below that temperature here, and that's going to be the entirety of all of this crude oil inside of here because it gets rebalanced every time it goes through the reservoir, this thing will turn off and you'll see the liquid flow past the aqua tuner and then jump across the bridge. So this loop here should maintain the temperature of about, well, a few degrees lower than what we have right here. So you can see this is now at 49, then the temperature is just dropping down a little bit more. And because of that, the liquid runs past this. So you can see how that's working right here. All this is set up to do is actually just to keep the steam turbine nice and cool, but I've used it in my base to actually cool down more things than just the steam turbine. It's a very powerful piece of equipment, so you can use it for many, many things. To run the steam turbine, I have this hooked up to a memory toggle switch. So essentially I want this thing to start running when it's above 150 degrees Celsius, but then I want it to turn off once it goes below 130 inside of here. This runs through an AND gate, which is connected to a smart battery, which dumps power, which can dump power into whatever piece of equipment you want to run. So this way, if we want to build up thermal energy down here, we can do so, and then use it whenever we want to. Okay, so focusing on this next loop here, we're trying to cool down the liquid that's running to this metal refinery so that it doesn't get too hot and we end up having issues with the refinery. So all I'm doing here is checking the temperature of this loop. So if this is, let's say, above 150 degrees Celsius, then I'm saying it's okay and we can run past this liquid shutoff right here. So then it goes back into the metal refinery. But if it's, if it's too hot, then we're going to continue to run it back around and around, just like you saw. Then as this metal refinery runs, it dumps its liquid into this liquid reservoir right here. And then once this metal refinery is full, the liquid continues to run around in a loop and we continue to sense the temperature of this. So if this is still, let's say we set this to 200 degrees Celsius, right? And we have our limits set to 150 and 130. If it's still hot enough to continue to transfer energy from this loop into the steam turbine above, then we want that liquid to continue to run around and around. So that's what's just going on right there. Okay, so I've set this metal refinery to run iron. Now I've done a whole video about different materials that we run through the metal refinery. Some of them actually will generate a net gain as far as the energy that it puts out. But that's a whole different video. You can check it out up over here. I've also done a whole nother video on the automation system that you're seeing right here, plus other options that are available. So if you want more in depth on the automation that's going on here with the storage bins and the inventory, check that video out. What's happening in this particular setup right here is I'm running on a safety stock system. So what we're first going to do here when this metal refinery is active, based on the automation, is we're going to build up the sum of both of these two storage bins right here. So I have 1,000 set in the smart storage bin, and then I have the secondary storage bin set to 2,000. So we'll build up a total of 3,000 iron, and then if we are at that point or above that point, we're actually going to turn off this metal refinery so a duplicate doesn't run over here and actually use up that metal. So this system allows you to build up a certain amount of metal and then it turns off. Okay, now because I'm using two storage bins right here, this allows me to fully deplete the first storage bin before I will ever re-enable the metal refinery. So this allows us to be nice and efficient with our duplicates' time because they're not constantly running over here just to build up a little bit of iron. They run over here to build up a lot of iron and then they leave it alone for many, many cycles. Now, because of the way that these storage bins are arranged, you can see that this one here fills up before the farther one. Now, I have noticed sometimes here that the auto sweeper gets a little bit weird. If you ever notice that, just change the priority on it a little bit and flip it back, and then it should even out. Not to mention, both of these you want to be the exact same priority. Matter of fact, I like to have all of these be the exact same priority. And if you're not using an auto sweeper, it's probably a good idea to have your duplicate that's running operation skills right here to have the same sort of level on storing. That way, when they finish, they turn around and deliver to that. Again, I did a whole video on that. There's ways to kind of get around that. But that's one trick that I'm using in my current base, and it works out pretty good. But I'm also using a sweep-only storage system inside of my base so that a lot of time doesn't get spent moving stuff into storage bins. I run all of my commands just using the sweep thing like that. So then the duplicate runs around and does the work. Okay, so we can see that we filled up the first storage bin. Now we're starting to fill up the smart storage bin. Now I don't want this smart storage bin to continuously run the entire cycle, so that's why I have it hooked up to a power shutoff. And if we take a look at the power grid here, you can see that I'm running this through the power shutoff and then onto the smart storage bin right there. And connected to this power shutoff, I have a clock sensor. Matter of fact, that's hooked up to all of this little automation right here. So I have a filter and then I have a buffer down here, and that's hooked up to a memory toggle switch. This thing will check whether or not the smart storage bin is full or not once per cycle right here. So its active duration is 1%. Its active time might be at any point during the day. I just have it set at the very beginning of the day. So you can see here, it checks it. Nope, it's not full. So therefore, the metal refinery stays active. Another blueprint you might want to use in place of the clock sensor here, if you want to check it more than once per cycle, is a clock pulse. So that might look something like this. So this system right here allows you to set the duration of the pulse right here in the buffer gate, and then it lets you set the interval between pulses right here. So let's say we check it every 60 seconds, right? And we get rid of this clock sensor because we don't need that anymore. So every 60 seconds, we're going to check to see if this smart storage has been, and if it is full, then we're going to disable the metal refinery. So you can see right there, it checked it. It says, yes, I am full. Therefore, the metal refinery has been turned off. So let's say I increase the capacity to this so we can re-enable it to 1,500. You can see that, oh, now once we go ahead and check this again, we will see that, boom, we've re-enabled the metal refinery. So we're going to run this once again, and we can see that the metal will pop out of the metal refinery, and now we're over our limit right there, so we've disabled the metal refinery. So that's how that works right there. So when you set this up in a larger system, you pretty much just have one master clock pulse, and then you use this blueprint right here many, many times. So this way you can refine as many different metals as you want. I use about 5 of them in my base right there, and all of them have an automated inventory system that you can set your limits on as well. And once you've connected all of these to the cooler up here, this is what's happening. So essentially we have the temperatures inside of here. They're at 126 degrees, and I have these memory toggle switches hooked up to the steam turbine and the power and whatnot. So you can see that it is able to kick out enough power to run several light bulbs up here every once in a while when it's just running off of iron. So let me increase this limit once again so that we can see it in action. So you can see the crude oil that comes out of this metal refinery is quite hot, so therefore we're actually able to generate a decent amount of power, right around 400 watts this time. So those 400 watts are obviously powering up these light bulbs, and yeah, you can see how that works right there. And then once the metal refinery system turns off for a little while, this whole thing is going to start to cool down, and we'll see the temperatures start to drop in here. So you can see we're currently at 160 degrees Celsius, but we're dropping relatively quickly. And then once we get down below 130, this whole thing will actually turn off. So there we have it. We're now below 130 degrees Celsius. So this entire system right now is dormant and nothing is happening. All right, so there you have it. That's the full system right there. All of those blueprints are available in the description below. Hopefully you guys have enjoyed this little episode here of Oxygen Not Included. If you have some other ideas or some other arrangements that you'd like to use, go ahead and share that in the comment section below or maybe on the Discord channel. Thanks for watching, guys. Have a great day. Stay awesome. Peace. Brothgar out.